all of these, the beacon chain, creating all of the, generating randomness, which allows block proposal for these shard chains, and, committing to finalizing the shard chains, and it's really cool. But in this talk, I'm going to mostly focus on a single chain, maybe Plasma. So, well, let's dive in. Before we have this kind of construction, I really think that we can have something very cool with Plasma, and I'm going to talk about some exciting stuff later on in this talk. So what is Plasma in the first place? Let's dive right in. Well, it's an architecture for layer 2, blockchain secured with an exit mechanism. It's kind of confusing, doesn't make any sense. Hopefully this will illuminate things a little bit. And I want everyone to have an idea what Plasma is, because the entire reason why we're building these systems, what decentralization means, is you have a reason to trust the internet system, infrastructure that you're using, right? We need to establish trust, so you need to know how this kind of stuff works if it's going to be adopted on a large scale. So, we have the Ethereum chain, we've got the Plasma contract. The Plasma contract is deployed to the Ethereum main chain and mined by a miner, right? It's pretty simple so far. This Plasma contract has an address, it has an ETH balance, and it acts as a kind of judge, as a kind of mediator for all of the funds that it's going to oversee. And notice that this mediator is deterministic, it is objective. There is no kind of question who's controlling this. It is automatically executed like a robot. A robot that has no opinions outside of just following orders. So, we also have this operator. The operator can be a single entity. It can also be, a proof-of-stake validator set, right? It's actually surprisingly easy to, turn this into a proof-of-stake system. So, we might as well log in some coins and do that. So, next we have the Plasma chain itself. The Plasma chain consists of off-chain data. This is where we get our scalability from. This is, stored up in the cloud. It's a whole lot of data. And here, it consists of on-chain data, like block commitments, as well as deposits and exits. And so this is all on the Ethereum main chain. And the key is that our security actually comes from and derives from the Ethereum main chain. So if the Ethereum main chain is to, hold up its properties of, censorship resistance and safety, then what we get is we get the same properties of our Plasma chain. We get that same level of security. And so while storing minimal data on the Ethereum chain. And so there's actually something fun that I heard. Well, you can actually achieve this kind of scalability stuff with cryptography just alone, using stuff like ZK Snark's rollup and some really cool tech that's coming out soon. But Justin Drake has this saying that I really love, where if you can't use cryptography, then try cryptoeconomics, because the cryptography is very expensive at this moment. So, it's pretty cool. I'm a fan of that little saying. So lastly, we have our users, of course. And so we've got Alice and Bob. Alice on the left, Bob on the right. It's very important that you know. Now, we have 3 steps, main steps for all of these Plasma chains. You deposit tokens, you transact on the Plasma chain, and then you exit tokens. So first, we're going to deposit some tokens. So Alice signs an Ethereum transaction, sends it to the miner mines it, and now it is recorded in the Ethereum chain. It reduces her ETH balance and sends that ETH to the Plasma contract to control. Sounds good so far. And so now we've got this deposit record. The deposit record is immediately kind of reflected on the Plasma chain. It is stored in the main chain. It is a little piece of data, not very expensive, but it is, it's a non-trivial cost of gas. And then that gives us 100 PETH. So this is a kind of, Plasma chain version of the asset. And this works not just for ETH, but this works for any arbitrary token as well as ERC 721s. Anything that you, want to, any asset works on one of these chains. Now, next you can transact on the Plasma chain. So Alice creates a Plasma transaction, and it's sending to Bob 50 coins, and it's sent directly to the Plasma operators, or maybe the validators, and created in a. They come to consensus on it. They form a block, and they submit that block to the. They actually create a Merkle tree of that block and a compact block commitment. So this is a constant size, basically a hash, which is submitted to the main Ethereum chain. That is a commitment to the block, and then the actual block data itself is made available for all users to download. So notice that the block is currently grayed out. That's because it's not yet committed to. And so eventually what we will do is we will mine a block on the Ethereum chain with that block commitment, and that will kind of commit the Plasma block to the main chain. And so now we have the security of the main chain. So, sounds pretty good so far. And we now need to, update the state. And so we have this, peth, and we're going to send it to Bob, and, minus 50 plus 50, and we're good. So we've transacted on the plasma chain, but the point of these plasma chains is we can transact a lot, right? We currently don't scale. We want to scale. Pretty simple. So what we can do is, notice that this transaction process, everything is going on, all the kind of main information is going on off-chain. Right? It's not actually being committed to the main chain. And there's only a constant size commitment to the main chain. So the larger the block, it doesn't actually affect what you're committing to the main Ethereum chain. So you can, instead of having one transaction, you can have a whole lot of transactions. Send them all to the Ethereum, the Plasma operators. They'll create a block, they'll create a Merkle tree, Merkle root, and they will submit that block commitment to the main chain. And so instead of being bound by the Ethereum transaction limit, which is like 15 transactions per second today, maybe 1,000 times x that, in a little bit, but still, we can already get these massive blocks just by using a kind of sensible cryptoeconomic mechanism like Plasma. So, how many transactions per second, you ask? Well, we're going to talk about it soon. So the last thing is exiting tokens, right? Bob wants to exit his coins, and he creates a transaction which exits which is like, I want to exit, sends it to the main chain. The main chain starts out this exit process, and there's 7 days for a challenge to be submitted. So essentially what happens is we have this challenge period at 7 days, and we wait for Alice, if Alice thinks that this exit is invalid and not actually, maybe it's trying to steal someone else's coins, Alice can send a message saying, this exit is invalid, prove it to this dispute, contract, and then the exit will be canceled. But in our case, the exit was just fine, and so it goes through, we wait, and finally Bob submits a withdrawal transaction, sends it to the main Ethereum chain, and receives reduces the balances on the Plasma chain, and receives the money on the Ethereum chain sent from the Plasma contract itself. So this is the general construction for all of these Plasma chains. It's pretty cool. Pretty, like, all of the Plasma designs, whether it be Plasma, Cash, MVP, etc., they all follow this same kind of format. So that's pretty cool. That's pretty cool. Now, unfortunately, this was only one transaction, and there's no point of having a coin on a Plasma chain if you only transact it once, because then you're just, sending it once, withdrawing it, and the gas cost is like you're not even saving any money. And so we really want like a huge number of transactions on these Plasma chains. It would be ideal if they could be massive, or at least have one humongous Plasma chain. That would be so cool, because then we get these cheap transactions for all of the Ethereum assets, and we can get them way sooner than we can see. And we'll see how many transactions we actually get pretty soon. So a brief recap of Plasma history, right? It's been a crazy journey with a lot of different crazy names, ending up with this kind of like last little Plasma thing, which I will talk about. Anyway, so first it started out with this white paper, right? We're climbing, we're starting the mountain. It had a general idea of the format of Plasma, but it was a little bit fuzzy. It didn't really didn't feel like you could really implement it just from that spec. And so what happened is Vitalik created this Plasma MVP architecture, which was really great. It had a lot going for it, but there were some clear flaws with this spec. And one of those flaws was confirmation signatures, mass exits, and no trustless like lines. So we'll talk about confirmation signatures very briefly. It's a pretty silly thing. So when Alice sent a transaction and it got committed to the main chain, it turns out that it wouldn't actually be valid yet. In fact, Alice needed to sign a transaction saying, I saw this message, and send it directly to Bob. This would make the transaction valid, and to be honest, that is a terrible UX. That would be so complicated to implement. You have to send sign two things just to send one coin. That's craziness. I don't know. It was not great. The next one is the mass exit vulnerability. This is the scariest of all, probably. So we have one transaction in this block, and that transaction is red. What does that mean? That means it's invalid. It means that it is spending more money than it actually has, right? This is just literally an invalid transaction. Alice is not sending this evil Mallory gerbil 99999 coins. That's crazy talk. So what is happening is that transaction maybe gets included into the Plasma chain because Mallory and the operator are colluding, some kind of, some nasty business is going on. So then Mallory, this evil gerbil, is going to submit an exit of all of those coins, attempting to drain the Plasma smart contract of all of its money, right? And it's going to reference that invalid transaction in its proof to the Plasma contract. Now, because of the way the Plasma contract was designed in MVP, it created this ticking time bomb where everyone had to exit within 7 days. And if they did not exit, well, you'll see, the people who did exit, they'd get their money back. That's great. But the people who didn't exit, boom, it would explode, and all the money would be sent directly to the person who had this invalid exit. Right, so this is extremely bad. If you're like asleep for a little bit, then you lose all your money with very, very little recourse. It's very easy for the Plasma operator to just go away and take a whole lot of money. Now, it gets even worse. We're talking about a massive Plasma chain, or a couple massive Plasma chains. So, like, in that case, we have a huge number of users. And if a huge number of users are all trying to submit exits within 7 weeks, or 7 days, maybe that's not enough time for all of them to be processed. And so, if you thought CryptoKitties clogged the Ethereum network, my goodness, this would be a nightmare. It just like breaks the whole system. You literally can't scale up to this point. So it's gone, supernova, game over, let's try again. So, no trustless like line. This is another important piece. We remember had this because this ticking time bomb exists. We need to check. Every user needs to check that there isn't an invalid transaction included in our block, which means they need to download and process every single transaction, looking for that single invalid transaction. This is a serious problem because it's great that they can exit, but the thing is that downloading and processing every single block, if those blocks get really big, creates a huge bottleneck. And so instead of getting tons of transactions per second, we have to download everything. And so that means maybe 100 transactions per second, maybe 1,000 transactions per second, but it's very limited by the client's ability to download the transaction. So that's not good. Next, more viable Plasma. Kelvin and Ben Jones actually created this spec that iterates on the MVP and removes those confirmation signatures. Thank goodness, that was needed to go. But then there was also this Plasma Cash's Plasma ridiculousness, pretty silly. But nonetheless, Plasma Cash came out, and so that actually got us a little closer, I would say. And so that kind of mitigated this mass exit vulnerability, and it also gave us a trustless light client. So we'll look at how this kind of works. What we did with Plasma Cash is we said, okay, each transaction is going to specify an index in a Merkle tree which corresponds to a unique asset at that index. And what that means is that gives us like these kind of, single assets at every single leaf node of this Merkle tree. And so exits will specify the particular coins that you are trying to exit, and challenges will kind of refute that particular coin in that particular index in that particular Merkle tree, particular. And so we have multiple, this actual information, I won't go into details, gave us enough information to cancel exits if they're invalid. Instead of forcing everyone else to exit, you just respond, proving to that Plasma contract that the exit was invalid, that the transaction was invalid, and we canceled the exit in the first place. So this meant that not everyone needed to submit a exit before that time limit. One person needed to submit a cancellation of that invalid exit. So that's pretty cool. And by the way, a deposit is burned to kind of like pay for the trouble. So no rust to exit, and the attack failed. Thank goodness. But there is more. Thankfully, we also have a trustless light client. This is actually pretty cool. So remember that the reason why we had to download everything is because we didn't know where in the block that invalid transaction would be located. But because we have a particular coin ID for every coin that we care about, that means that if Alice owns maybe 5 different coins, Alice is only going to download 5 different Merkle trees. Or in this case, Alice owns 1 or 2 coins, and they only need to download those particular trees. And so now we can scale the block sizes up, and the amount of download, like the size of the download, scales logarithmically, which basically means you can scale it, exponential logarithmic. It's an amazing thing. Oh, look if you don't know, logarithmic. Oh, God, I love it. Anyway, so that means, maybe 1,000 transactions per second, or maybe even like 10,000 transactions per second. It's, pretty good with this light client. However, unfortunately, we introduced another bottleneck. Really sad. We have these huge transaction history proofs, which means is that if you're downloading the history for your coin, you need to download that history for every single block that's ever published. And that means downloading a huge amount of information. And so with like 1,000 transactions or 10,000 transactions per second, it could be like a gigabyte of history per coin, which is crazy. Like, it literally just doesn't make sense. Once again, it like breaks the whole thing. It's insane. It's very, very sad. So that's a problem. The other issue is that we now have, there's no fungible token support, no good fungible token support. So the idea here was, okay, every single single index has a different unique asset, and so maybe you have a few dollars in some of the indices, and maybe you have a $5 bill at, another, or maybe a $100 bill. So if you want to send $106, you have to send 3 transactions with a 5 and a 1 and a 100. This is like a usability nightmare, to be quite honest, and just doesn't work once again for wallet software. It's like pretty bad. So yet again, another issue, another big leap that we have to hurdle. Like this, we're getting closer, but we're still not there. So Plasma Debit came along, Dan Robinson, super awesome, kind of addressed this no fungible tokens issue with combining state channels and Plasma. And that, that got us a long way, that got us significantly further. It also helped with the transaction history proofs. So this was along the right path. It was getting there. But then, a couple posts by Vitalik and 17 Plasma implementers calls later, my God, this has been crazy. And yet another Plasma, thank goodness. Plasma Prime. This is, I would say, I feel like we have finally hit the peak of a mountain, and it is very nice, and some sun is coming up. I have felt, to be honest, like all of these, all of the research leading up to now, there's always been like that glaring issue that you really wanted to solve, but Plasma Prime, it's looking downhill. It's looking downhill. I'm very excited, as you can see. So what does it do? Well, it addresses this no fungible tokens issue with just replacing all of the leaf nodes with a single denomination, and instead of having a single, like a small Merkle tree of a bunch of non-fungible assets, we have a huge Merkle tree, and our sends, they specify a range of tokens. And so if I'm going to send you some coins, I'm going to send you, tokens 0 through 105. And so this preserves our property from Plasma Cash so we get a light client support, but it also allows us to get this fungible token support. So it's actually pretty cool. And we have the same simple challenges that we have in Plasma Cash, so we get to build on that research. Another thing is it addresses the huge history transaction proofs with some RSA magic, which you can learn about in a Plasma implementers call that we had recently, as well as a few blog posts by Vitalik. You can actually prove that there were no coins transacted in a long range of blocks with a single proof, a single witness. And so what does this mean? This means that as a user, if I don't transact my coin, I can just, download one piece of information that kind of covers the entire range of blocks and proves that I have not transacted my coin for maybe 100 or maybe 1,000 blocks. So that saves us 100 or 1,000 or way more Merkle tree branches that we would have needed to download otherwise. So we're back down to a reasonable size, kilobytes, maybe megabyte, whatever, transaction history. So our transaction history, instead of growing linearly with the number of blocks that are being added to the Plasma chain, it's growing linearly with the number of times we transact that particular coin. Much more reasonable. So this 10,000 transactions per second limit, maybe like 100,000 transactions per second. That would be like incredibly cool. And it doesn't feel like there is a kind of, thing looming ahead that keeps us from doing this in a like kind of implementation production setting. So bonus, while all this research was going on, we kind of figured out how to do atomic swaps as well as, batch auctions, some simple designs. You can just kind of plug and play with these auction designs. And so we can build on this atomic swap thing that is native to the Plasma chain, and we get this kind of scalable crypto economics. We get the scalable, payments and exchange at the same time. And so this is really, really cool in my opinion. And so even cooler, right? Okay, so I'm saying all these things, you have now the intuitions for what all this means, but not only is this research here, but River Key, for a friend of mine I was telling about, I was like, man, this stuff is exciting as heck. I don't know what I'm doing. Plasma, I don't know what the problem is yet. Like, I don't know why this wouldn't work. And what he did was he implemented in a single week, literally 1 week, you can check the commits, a kind of like pre-alpha, kind of basic version of a testnet of this kind of plasma variant. And so this is literally, right now it is a little bit, we're going to kind of release, hopefully tonight, maybe tomorrow, but a kind of like pre-alpha. It's not quite. This was literally 1 week of work. But the point is that it is actually possible to create this chain in a very reasonable, it's a clean architecture finally. And this is the kind of process that I've noticed happen all the time, where you research a problem over and over and over again, you iterate, and you find out there's a new problem, there's a new complexity, there's a new area of difficulty, there's a new bottleneck, and you kind of plug those holes and you kind of expand your processing capacity. But this is the first time where a scalable plasma chain kind of makes sense in some ways, which is super cool. And so, this was implemented in Python using LevelDB, it's super simple stuff, basically so that people can read it. Also in Viper, I should have written that up there. Shout out to Viper, super fun. And so, great, there's this kind of like, what lies ahead? And everyone knows, who does hill climbing stuff, that this could be a local maxima. But nonetheless, it looks pretty good, right? With one thing that's really cool is we can actually, the smart contract side of things can stay the same as we scale this operator. So as we, kind of optimize the kind of back-end side of this plasma chain, we can actually keep the same block structure, keep the same general format, and instead we're just scaling, maybe a computing cluster, so you can shard Merkle trees very easily. So that's cool. So like 100 transactions per second, 100,000 transactions per second, and like the thing is that I was not going to be satisfied, or I'm not satisfied until a crypto-economic mechanism, a real secure blockchain, like a blockchain that is really decentralized and good, can process huge amounts of transactions per second that decentralized architectures have been able to process for a long time. So like this is the goal, the explicit goal, and it is actually it's seeming good. So another cool thing, just like randomly, even in a sharded context, these plasma chains do make some sense. So you can actually, as you're building up the beacon chain, as you're building up the shard chains, you can actually create a plasma chain that has a plasma contract across multiple shards. So if you spawn your ERC20 tokens on a different shard, then you can actually deposit into the same massive plasma chain and transact that thing independently. That's pretty cool, and you can even commit to token allocations on chain with a Merkle tree, and then immediately transact those coins in the plasma chain in a scalable setting. So you don't even need to like register the tokens themselves on the main chain. So it's pretty cool. These are like some very cool designs, and hopefully, and I actually right now I'm not seeing why not, we can scale to a very large, kind of like global internet scale. Like we need to make sure that these crypto-economic mechanisms, if we're going to say that decentralization is the way, this is the future, this is the way we should do things, well, we need to show that it actually works for supporting a large number of users. And so, of course, Ethereum 2.0 has that kind of vision in it and is actually, very far along, and I wish I could, I wish I had an hour so I could just do the next talk on Ethereum 2.0, or on Serenity, but hopefully even with this, with Plasma next to, Ethereum 1.0 or Ethereum 2.0, and more, of course this is not the only technology that's going to be required for this. Hopefully we can actually support this kind of real global economy, and hopefully we can create a, the crypto economy, make sure that it is self-sufficient. This is going to be something that I don't see like external value coming into the crypto system. I think this is the point where like the external value has come into the crypto system. People are like, oh wow, this is really cool, and are speculating all day. However, we need to actually generate value within our economy and actually create like this internet future thing, I don't know, this kind of internet land that is actually free and decentralized, which would be pretty cool. And hopefully this will be enough to really spread the memes of decentralization as well as the memes. That's the fun one. Anyway, so that is that. I just put this here. I'm just like shilling Uniswap for a slide. I don't know. That was interesting. Anyway, I'm also shilling Cryptoeconomics study for a slide. Cryptoeconomics study. It's a course and a book written by Jing-Lan Wang. And I'm working on the lectures, and so I just like put through a couple lectures. It's not just me working on the lectures, to be honest. There's also, Kevin who's working on some lectures, as well as Jing. So like, this is a super, super cool thing. And once again, this was the beginning of my talk, was like, okay, we need to make sure that everyone is included, that we spread this information, because everyone has something unique to contribute, really. And to be honest, if we're going to create this like new future, free, amazing economy, like the only way that we're going to prevent it from kind of degrading into a centralized, basically control system, power structure that we hate already today, well, it's only going to happen if we have people from different communities that have the actual information, access to this information, to build it together. Because otherwise we're going to forget certain things, we're going to create systems that don't actually promote equality and instead kind of promote a single person's interest. I fall victim to this too. Like, I do things that I really absolutely regret while completely having the right intentions. I will make mistakes. So we all have to remember we're human. We need to make sure that other people kind of can balance us out. We're in this together, and like hopefully this whole thing will work. So check out that DevCon or scalingdevcon.com, that ridiculous website. By the way, it's probably broken right now, but whatever. But more importantly, check out the Plasma Prime implementation. That is, I'll send out a tweet or two and you can download it and actually like send transactions and mess around on a Plasma chain and exit. And then let's scale this thing up, because it's actually possible. Thank you.